We're going to finish up 5, 6 with perpendicular lines. So we're going to look how to write an equation of a line that passes through a given point perpendicular to a given line. Lines that intersect at right angles are called perpendicular lines. There is a relationship between the slopes of perpendicular lines. Two non-vertical lines are perpendicular if the product of their slopes is -1. That is, the slopes are opposite reciprocals of each other. Vertical lines and horizontal lines are also perpendicular. So in their specific example here, they show a line with a slope of -1/2, it's going down 1/2, and a line with a slope of +2, it's going up 2/1. And they cross at a nice right angle. And of course, horizontal and vertical lines are always going to cross at right angles. The height of a trapezoid is measured on a segment that is perpendicular to a base. In trapezoid, ARTP, segment RT and segment AP are bases. Can segment EZ be used to measure the height of the trapezoid? Explain. Well, so they're basically asking us, is this line perpendicular to the other two? It fails the eyeball test quite miserably. If we actually go and find a line perpendicular to RT, instead of its slope is going up 1/1, our new slope needs to go down 1/1. So perpendicular would be like that. I missed my line a little bit, but I hit it closer than theirs. Okay, so that is a big old no. And explain. EZ is not. And this is our abbreviation for perpendicular to, we can say either one, RT, I guess we can put them both, or to AP. Definitely not. Write the slope-intercept form for an equation of a line that passes through the point 4, -1 and is perpendicular to the graph of 7x minus 2y equals 3. Okay, they were a little bit rude because if they had solved for y and put it in slope-intercept form, I could easily grab out my slope, and they didn't. So we're going to have to subtract 7x from both sides of the equation. So I have -2y equals -7x plus 3. And divide both sides by -2. So I have y equals negative divided by negative is positive, 7/2 x minus 3/2. We really don't care about that, but I can't help myself. So my original slope is 7/2. We said if we want the slope of a perpendicular line, it's the opposite reciprocal. So it would be -2/7. So now I've got a point, I've got a slope, I can use my point slope form again. So y minus the y part of my point, so minus -1 is going to be +1 equals m, which we said was going to be -2/7 times x minus the x part of our point. We want it in slope-intercept form, so we need to distribute our -2/7. So I have y plus 1 equals -2/7 x, negative times negative is positive, 2 times 4 is 8/7. If you want to write your 4 as 4/1, if that helps, go for it. And we're going to subtract 1 from both sides. Now when we subtract with fractions, then we need a common denominator, so I'm going to write that as 7/7, just to make it easier to see. So I have y equals -2, that's a -2/7 x plus 1/7. They say a picture's worth 1,000 words, so here's what Algebra has to say about the lines 7x minus 2y equals 3 and y equals -2/7 x plus 1/7. Obviously, I kind of lost my fractions when I typed it in because it changed it to decimals, but that's okay because they sure look like they are perpendicular and it goes through the point 4, -1. Write a slope-intercept form in an equation of a line perpendicular to the graph of 2y plus 5x equals 2 and passes through the point 0, 6. Once again, they weren't so nice because they gave it to us in standard form, and I wish it were in slope-intercept form. So I'm going to have to subtract 5x from both sides. So I have 2y equals 2 minus 5x, and divide both sides by 2. So I get y equals 1 minus 5 halves x. Now, this isn't written in the order that slope-intercept form is normally in, but whatever the coefficient of x is still going to be my m. So my original slope is negative 5 halves. So that means the slope of the line perpendicular, remember the upside down capital T is for perpendicular, would be positive 2/5. So here we go again. Y minus the y part of my point equals the slope that we found was 2/5 times x minus the x part of my point. Oh, subtracting 0, that's fun. When we subtract 0, not much happens. So all I'm going to have is y minus 6 equals 2/5. That'll be easy to change to slope-intercept form. So I get y equals 2/5 x plus 6. And I'm pleased to report that GeoGebra says that we met our goal. We found an equation of a line that is perpendicular to 2y plus 5x equals 2, and it passes through the point 0, 6. In summary, two non-vertical lines are parallel if they have the same slope, and two non-vertical lines are perpendicular if the product of their slopes is -1.